All right, all right. So, hello everyone. Welcome back to another workshop for the Built on Hackathon. And this workshop is about QuickNode Streams, where we will learn what QuickNode Streams are, how to use them, and why to use them, where to use them, plus how to actually set up a stream. So with us today, we have Nick from our QuickNode team who will take us through the stream's journey. So Nick, I'll pass it on to you if you can give everyone a brief introduction about yourself and if you want to convey a special message or anything specific to the hackers.
Of course. Thank you, Sahil. I'm really excited to present you guys Streams, the most powerful data pipeline ETL solution out there in Web3 space. I'm really excited to take you through the user experience and show you all the powerful features we've built. And I am convinced that Streams would be the backbone for most of your hacking. Just the way it is designed, it is perfectly tuned to get you started in seconds. And then on top of the all logic we have with the filters, with the key value store built in it, you could hack within hours and like even minutes. And I've personally witnessed that myself while being a hacker a long time ago and attending hackathons, that dealing with blockchain data takes a long time. If you're starting from scratch, if you're learning about different kind of RPC calls and entities, that can take you so long. And yeah, maybe these days with Cloud AI and other solutions like ChatGPT and other AI models, you could get started quicker. But we've already figured everything for you. So yeah, back to you, Sahil.
Thank you so much, Nick. So, Nick, what I'll do right now is first explain everyone a little bit about what kind of bounties or prizes we have for streams, and then I'll pass it on to you so that you can explain everyone along with me about streams and how streams work and how I myself as a hacker can set up a stream. So we have three prizes for streams. They are just like or very similar to the marketplace and functions prizes, which we saw in yesterday's workshops. So we will choose three winners, whoever applies to the streams bounty or streams track. And the first winner will get $7,000 in cash, $5,000 in QuickNode Streams credit, $5,000 in Limestone Networks credit. Limestone Networks is a cloud provider, and $10,000 in AWS credits. The second winner or the runner-up would get $3,500 in cash, will get $2,500 in QuickNode Streams credit, which you can use towards your streams, which you create during the hackathon, and you can keep using those streams even after the hackathons with those credits. You will also get $3,000 in Limestone Network credits, $5,000 in AWS credits. And then the third winner or the second runner will get $1,500 in cash, $1,500 in QuickNode Streams credits. They'll also get $2,000 worth of Limestone Network credits and $5,000 worth of AWS credits. So we have a lot of exciting prizes up for grabs for streams. So make sure you follow along or watch Nick very closely as he explains to all of us what streams are and how you can set up your own stream. So I'll pass it on to you, Nick, to take us all through the journey of streams.
Thank you. These are really nice put together prizes. I really appreciate you guys putting together Limestone Networks and AWS too, because I think for the use cases that our participants would build out with streams, they definitely benefit from having some place to store this data and some parts of their backend. So having these partners put together in those nominations really simplifies the way to move from hacking to production. So streams is, as I mentioned, a really powerful real-time and historical data ETL solution, which means that you could extract this data very reliably and place it in any data storage data warehouse of your choice or a webhook server for real-time processing. With streams, you could get instant access to all the essential data sets For EVM chains, for some of the UTXO chains, we support Bitcoin and Solana. So you could cross-hack multiple chains together and come up with unique use cases such as DeFi applications and multi-DEX tracking or other ideas you might have. With this exposure to different kinds of data sets and chains that we support, and today we support up to 25 chains. You could find the whole list here on one-click backfills. We actually have a page that lists all chains we support and the amount of data it will take you to like backfill the whole chain. But for most of your use cases, you most likely won't need the whole data for the whole chain. And we'll take a look at the Streams dashboard in a second to see how to get started in seconds. I just wanted to make sure you understand that ETL stands for extract, transform, and load. So we ensure guaranteed extraction and delivery of these messages from blockchain nodes. But as they reach your destination, you could have a custom code put together in filters that can do magic with evaluating the payload, filtering it out. For example, if you want to get all the swaps or ERC20 transfers, this is something you can do easily with QuickNode Streams and this filter feature. The key value store lets you store this data in an interim database for calculating ongoing balances, market caps, or most commonly, key value store is used for wallet tracking. And you could manipulate this key value store through REST API, through Streams, and put there your wallet addresses that you could filter against. And we could also look into and talk about this in a moment. The list of our destinations supported is very wide. We support native integrations with Postgres, Amazon S3 and S3 compatible storage, Webhooks as the most ubiquitous destination, Snowflake, and the list of other destinations can be extended with functions. Yesterday we had a how to get started session for QuickNode Functions. That could be this interim layer for any sort of destination you want. So you could actually connect your stream to a function with any custom code. So without any further ado, let me just jump into QuickNode app and show you the dashboard from where you'll get started with creating your first stream. So once you go to QuickNode app, on the left side, you'll see streams. Once you click here, you'll be shown this empty state view where we explain what you could do with streams and also some of the templates to get started. Before I dive into these templates, I'm just going to create a very vanilla stream with nothing else other than selection of data set, chain, and maybe some branches of data. So in this drop-down of chain and network, you could pick one of supported chains today with Solana grayed out. We invite you to Solana private beta, and everyone participating in the hackathon is encouraged to give it a try. And if you're building on testnets, you could also pick one of the supported testnets. For the sake of the demo, let's pick base chain. And from the list of data sets, you could find all the options that would be essential for your analytics, for your real-time data tracking needs. We support blocks, receipts, transactions, and all kind of traces that are supported by the chain. Traces are essential for tracking smart contract interactions, but for the most part, everything is logged within the logs. And you could find more details, what's inside each payload inside our docs. But what I personally find very helpful is once you pick the data set and you scroll down to the payload section, you could actually click on view row payload, and you could see first truncated rows of your payload and understand what's inside there. And of course, you can download it and also cross-check this with the documentation. Once you pick the data set that you need, and for our demo, let's pick receipts, because receipts will most likely have all the essential data you need for event tracking on EVM chains. Then the rest of the settings you need to pick are your stream name has been pre-generated. You could modify it. Let's put demo here. The batch size will determine how many messages will accumulate for this data set before spitting it out to you. You could leave it as one, and we'll just keep on delivering one message at a time for this data set. And then the other section here determines the range of data you want to start to be streamed to your destination. You could pick a block number, and we will start streaming exactly from this block in a sequential order, just one message at a time until you acknowledge it on your end. Or you could start from the latest block, or you can even end your stream at a specified block number. For the sake of the demo, let's pretend we're starting from the latest block on base chain and we're never ending the stream. And then in the section stream payload, this is where all the magic with filters and transformations happen. You could modify your payload and use any kind of custom JavaScript code without external dependencies. So you're only limited to a few built-in libraries, which is enough, and it's essential for you to manipulate the data, make some checks, use key value store within here and whatnot. Let's just start with the raw payload, and as I progress in my demo, I'll show you other steps. Rework handling is an important section if your use case revolves around accurate real-time data. Your streams can have two approaches to handle reworks, and reworks are those events when part of the chain validators for validator-backed networks, such as Ethereum, they don't agree on the contents of your blocks, and you have deviating segments in your blockchain for some validators. It's easy to spot when the parent block hash is not connecting to your hash in the current block. And we're doing all this tracking for you, so you don't have to worry about witnessing those reworks, which can potentially influence the correctness of your data, as you might be getting streamed or querying, if you're dealing with RPCs, some of the blocks that were rejected by validators. So that's what I mean by validity of the data. And you could restream on reorg in those examples, and that would be the easiest way for you to deal with those events, and then determine how you handle that on your end. Since we've picked everything here, we could progress to the next step, which is picking the destination. And as I mentioned, in the list of destinations, we support some of those native integrations, and you could also pick or create your function, where you could integrate any sort of external storage, such as MongoDB, ClickHouse, you name it. For the sake of the demo, we could start with a simple webhook server. And our team has put together some starting points for you in pretty much all the most commonly used languages, such as Node.js, Go, Python. This is very easy to just copy and get started. But I'm going to illustrate that by using a typed webhook tools server that just spins up a server for you. And once you go to this page, you could click on the webhook URL to copy the server. And then I'm just going to put it inside the destination URL here. And we have a couple of other things we could tweak and tune in here, which are compressing the payload to save on the bandwidth. Since I'm going to show you the messages coming out of streams, I'm not going to compress anything. And then you could include metadata in either header or body. Let's include it in the body so that you could see what's inside the metadata that way. And the rest of those parameters determine our retry logic. So for example, if your webhook is not available anymore, or something else happens on your end, we're going to follow this approach. We're going to retry delivering data every 1 second, and we're going to pause the stream after 3 retries as soon as we exhaust those. So you could bump it up, you could increase the timeout. And once I hit on test destination, we're going to spit out the first test payload that you see here corresponds to receipts data set. So what we have here is an EVM receipt with all the transaction details for base. And for some of those transactions, we have logs emitted by the smart contracts for some of the events that were used in it. Since we don't know really what's inside here, we could talk about actually decoding this data with streams in a few moments. But that's pretty much all the essential data you need to consume on your end when you're dealing with with smart contract events. And once I hit create a stream, everything is flowing in really nicely. We will spin up the infrastructure and start streaming those blocks as they get finalized. You could track your current progress here. And once I switch over to this view for the webhook, you could see that those messages keep coming in, and they are delivered in real time and then sequential order. So that's how easy it is. It was me talking here really longer than potentially you taking the time to go ahead and create it, because it's like a few clicks, and in a few clicks, you're getting streamed all the essential base data that you could also keep track of with metrics, logs, and other ways like REST API.
Right. So Nick, I have two questions, which a lot of our users might also have. So the first question is, I, as a RPC user, can get all of these data sets, like receipts, logs, even transactions, from RPC as well. I can put a filter using a webhook on chain, and as soon as the condition for that filter is met, I can get the data, right? So when would you suggest, or what are the scenarios when you should be using streams over webhook, or it's every time? Because in webhook, I can, create some client-side filtering. So, but with streams, I'm getting a lot of data. So is there a filtration part where I can just get some specific data, whatever I need? So it's basically two-part question. The first is why streams on top of webhooks? Why streams versus webhooks? And how can I filter the data, or how can I get specific set of data or specific section of data in a large data set?
Of course. Sahil, just to make it clear, you're referring to WebSockets, right? Because some of the EVM and Solana chains, they provide the alternative interface for streaming WebSockets. And in our documentation, you could find these references for every chain. Like, for example, Base has some of the WebSocket methods here in the Ethereum JSON RPC API. And what Sahil referred to is a way to get this data stream. WebSockets are great for quick experimentation, but they're not very reliable for production use cases. The whole idea of us building out streams is making sure that your train is running on the right rails. And our rails have been used for a year by many enterprise customers for their real-time and historical data needs. What is great about streams is that you could integrate that with Postgres, Snowflake, and connect it once and forget about this. So we ensure guaranteed delivery. If something happens with your webhook, let's say, for example, here, I'm just putting down this webhook server that we've previously used for the demo. And if I move over here, you can see that the stream has been terminated. No data has been lost. We've acknowledged with the previous webhook server that the message last processed and received were this one. And once we just modify our stream here and update this settings page with the new webhook link and save those changes, we could continue from the last acknowledged point seamlessly. And with WebSockets connections that are constantly dropping off, you end up retrying creating them. It just drives you, and you cannot focus on actually building your product unless there is a reliable like foundation and pipeline for you, or my analogy with rails and trains. And yeah, we keep on receiving this data from that point. The second question that you've asked is, how can we reduce this data footprint? Especially for some of the very tangible chains, like data-wise, Solana, for example, has really large blocks, varying from 10 megabytes up to 100 megabytes. So how would we deal with that? One of the ways to tune to a specific part of the data within those receipts and potentially transactions or other data sets like traces is to use those filters. And we've prepared some helpful templates for you. For some of the use cases, getting all the ERC tokens would be enough. And we see customers using it for analyzing token movements. market cap, and other like financial use cases are really powered by these standards for tokens. Since they are standardized and they emit the same events, it's very easy to tune your streams to those specific transfers. For that, we're using the filter code that does the following thing. It has some of the helper logic here that can help you parse and strip some of those binary representation of data. As we could see here, for example, when you would parse those logs with topics, you need to have some logic behind decoding that. And we've prepared that for you. Within the actual function that does processing of incoming data, which is the whole payload you get from us, we would verify if for the stream data, inside the receipts, we'll have the Ethereum events corresponding to those ERC20 transfers, ERC721 like transfer shape, or ERC1155, which stand for NFT standards. You could experiment with this code. You could run those tests endlessly using different test blocks. I'm currently using Arbitrum, and this chain has already more than 266 million blocks. So you could go to an earlier block, for example. Let's rewind the test 100 million blocks back. And you could see that 100 million blocks back at this block, there were some ERC20 transfers. And this code can help you make some helpful calculations within it. So we're also attaching values, contract addresses, and other helpful data. And as you can see, the example return is sized at 2.41 kilobyte. To Sahil's point, we've reduced this up from 27 and 61 kilobytes down to 2 kilobytes with pretty much 91% of data reduced. And if you were to backfill this whole data, it would be within this range. But once you move over to stream destinations and you get to pick your compression on the webhook side, you'll see even lower estimates. And in this example, we're reducing our backfill volume down to 253 gigabytes for all transfers on Arbitrum. These are some of the helpful examples we built out for you. So once you go to Streams dashboard, you'll see examples on how to track Uniswap swaps, how to track transfers, and transfers from some of the specific addresses too. And if you use this template, you'll find some of the helper methods, such as QN, contains list item that operates with your key value store. And as I mentioned, Key Value Store is a managed database that we offer you absolutely for free, and we'll let you store some interim data or refer to some data points in order to filter your payloads inside streams. So in this example, we're checking if all the transactions contained within this wallet store, if all the transactions within the stream contain addresses from this wallet store. And let me switch quickly to our documentation for Key Value Store, explaining you that we have lists and sets as two entities that you could operate with. And typically for tracking like wallet interaction, we would encourage you to use lists as a array of wallet addresses that you could name as my list, or in this example that I've shown you here, we're calling it a wallet store. And we're just going to verify if inside the wallet store there was, or if inside the stream data that is coming in the stream, there were any transactions matching those addresses inside the key value store. Yeah, and as we see here in this example, this filter did not return any data. So you won't be actually paying or exhausting any of the paid gigabytes with streams in that way. This is really powerful, and lots of our customers and hackers use Key Value Store for building out wallet use cases and notifications. So for example, you onboard someone in your app and you put their wallet address inside this Key Value Store, and then you use this stream as a way to send you a notification if this wallet has been sending any transactions. What's really cool about the key value store is that it's dynamic. So you could update your lists and expand the set of addresses at any point of time. So you don't have to worry about stopping and resuming your streams or not having access to it, as you can access and modify all this data through REST API. Yeah, and Sahil, did I answer your question about reducing the data footprint?
Yeah, absolutely. And Nick, you also showed that once you took down that other webhook which you already had set up, the stream automatically detected that the destination is not responding, and it automatically stopped, right? So that you do not waste any processing or data. So how do I, as a user, get to know the reason behind the stream termination?
Oh, this is an excellent question. So how would a user know if your stream got terminated or something happened? So we support the notification emails here, and you could put in your email to get alerted if something happens with your stream whenever it's running. So for example, if it was terminated by us or something else happened, and you could always check all these messages and actual issues in the logs. So in our example, the webhook server got taken down, and we got a 400 message from typed webhook website, so that's why we took it down. But anything can happen. Maybe your whole infrastructure went down. Maybe AWS got blocked on your end or something else. So yeah, those notification emails are helpful. But what I personally find great for tracking your stream status is also using our REST API. You could retrieve your statuses and update them in real time and have this logic built in within your app. So what we see our customers doing is they set up those notification emails to get personally alerted, but they also have some logic that consumes this REST API and restarts those streams. I think you're muted, Sahil.
Yeah, so this is helpful. Like for a user, seeing all the logs, like what happened or what is happening, is very helpful for a user.
Yeah, I think there is one helpful feature we could highlight and let our hackers know that we've released it and we're going to keep on improving it. As I mentioned to you that even if we filter those logs and specifically like ERC20 transfers down to this representation of data, sometimes it's not really helpful to understand what's happening inside here. The reason behind this is how Ethereum operates with data, especially like events that are emitted whenever smart contracts transact on chain. When you transact with, let's say, USDC tokens, user interacts with USDC smart contract, and they call transfer function that logs and writes those transactions on chain as like receipt logs. And for you to understand that, you need to know the smart contract definition of the data. We recently released a feature that can help you decode this data and understand what's inside those logs right within the filters. Some of you might have heard of ABIs, which is Application Binary Interface. And this is a way for Ethereum smart contracts to define those events per contract. We have the smart contract toolkit available on QuickNode website. And once you go here, you can interact and learn how to integrate smart contracts and also see their ABIs. So for example, if I click on Uniswap, you could see they have all sorts of smart contracts that they use as part of their protocol. And if I click on, let's say, their factory contract that creates new pools on Uniswap, you could see this set of ABIs, which is essentially all these events that emit are emitted whenever somebody interacts with parts of the smart contract defined here. And you could see these ABIs on either scan too. So this is not something that is hard to fetch these days, especially for EVM chains. So you would deploy a new pool, and then whenever this pool is deployed, it would emit an event like pool created. And this pool created has the following definition. And those data types like address, unsigned in 24, they just define the length of those data fields inside topics. So the long story short, you don't have to figure all of this. You could just use streams decoding by passing in ABIs. And in this example, I have a lengthy ABI that includes transfers, swaps, mint events, which are commonly used by many smart contracts. So you could build a stream that gets all swaps, and you don't have to even worry about figuring out right topics or something else. So you have all this ABI event definition here. And what I do in the next line is I call this special function we've added recently to filters that does decoding for you. So you call decode AVM receipts against the receipts, and you pass over an array of ABIs if you have many. And you can also store this ABIs inside key value store. And this helper function would return all the decoded receipts. And in this example, inside the filtered receipts, you'll see that we've successfully decoded approvals for owner, spender, transaction hash, and value. So approval event is usually used by decentralized exchanges to let the spender to spend the exact token that is specified in this address, I think. And there are other events if you like download the payload, or for the sake of demo, I could just minimize the set of ABIs down to transfer. And in that case, what this filter function would do, it would just decode all transfers corresponding to this ABI. And if I run this test, you could see that we've successfully decoded logs for transfers. We could see from 2 values and transaction hash. And yeah, that's how easy it is to decode data with streams today if you have access to ABIs. And we have something on our roadmap that will let you get access to those ABIs soon too, right inside here. I'm really excited about that. I'm pretty sure that for hackers, this would be very valuable, because instead of them having to figure out how to transform this data and how to make it human readable, they could do all of this inside streams and then get access to, let's say, transfers that have value more than X, and build other exciting filters and use cases around this logic. So yeah, this is streams in action. I showed you how to create your first stream, how to use filters. You could play around with some of the destinations options we have. I'm pretty sure some of you will find flat storage helpful for your hacking and PostgreSQL managed databases on Amazon, or you can spin up one on the dedicated server provided by our partners. So yeah, this is streams in action.
Thank you so much, Nick. So while you were showing us all the possibilities that are possible using streams, I just had this one thought that what are some unique use cases, or what are some unique implementations of streams we have seen until now? We don't need to share the names, but just a workflow or just a unique implementation of this tool we have seen until now.
Oh, there's so many. I just saw someone using streams for tracking their paymaster interaction for ERC 4337, like account abstraction. And this is one of the unique examples, because it involves creating those streams programmatically, and the user ended up spinning like 200 streams, and they are able to orchestrate it efficiently with REST APIs. Another exciting example I saw is I I spoke about like factory on Uniswap. So factory pattern on EVM chains makes it so that for every new pool, this contract would end up creating new contract. So what we see customers do, similarly to some subgraph, let's say indexing logic, they have a stream that is monitoring all events by Uniswap factory. And then whenever a new pool is created, they create a new stream that listens to events from that specific pool. And they all do this streaming in parallel, which makes the indexing super efficient. So we saw customers indexing Uniswap data in like less than a day with that approach. This is very unique.
Yeah, that's so cool. And I mean, what I like about streams the most is first thing that we support streams on so many chains, and the second thing is that it's such a versatile tool because of filters. Like we can get or we can reduce the data to such a specific data set or such a specific value, which is just valuable to me. I mean, it's just amazing.
Yeah, I definitely acknowledge that. Like I would say that 80% of our customers use filters, and this is the most commonly adopted feature by them.
Yeah, and for all the hackers as well, like who are watching, we would highly recommend using filters because majority of the time you won't need the entire raw data set. You will need a specific data from that data set. So make sure to use filters, and if you have any questions or if you have hard time creating a filter for the data which you need, feel free to leave a text in the streams channel on our Discord, and we will help you with the filter code and anything related to streams in general as well.
Yeah, exactly. And if we take time to respond, what I personally find super helpful when I deal with the filters myself is the use of Gen AI. So I'd use ChatGPT myself for Claude AI, and I'd use some of the filter codes that we've put together for our customers and visitors as a starting point. So this is the role payload before filtering. And I could save it locally, and I could also run this test here. And in this example, we're filtering like pancake swap events. And I could also save the response and the code and pass it over to ChatGPT and say, hey, ChatGPT, I'm trying to do this. Can you help me improve the logic inside this JavaScript code? And like 9 times out of 10, it does perfect job from the very first prompt. So that's how I would approach it if I were to hack an experiment with things and you're sort of new to, let's say, JavaScript programming in particular or our data sets. But we'll definitely help on Discord. I'm personally checking all the messages there with you, Sahil and Carl. So
plus, while creating those filter codes, if you run into issues while running the test, you will also get very clear error messages right below that, so that you can know that
exactly. So if you're trying to access something non-existent or return example, let's just return a non-existing message. It would give you out a stack trace with exact lines when things went wrong.
Yeah, it's very helpful while developing. Yeah. So Nick, you mentioned Gen AI, right? I use that all the time to create filters. What I do is exactly how you mentioned it. Like I just give the LLM model an example that this filter code gives me this data set, and I have this data set. How can I get this particular value from this data set? So it just looks at the previous filter code, understands the syntax, and gives me a new filter code for my newer use cases. Yeah, it's very helpful in that sense. So, Nick, do you have anything else to mention about streams or anything else to cover?
The only thing to mention is that we're improving our latency and architecture every day. For EVM chains, we're blazingly fast. For Solana streams, we're still in private beta. And although it our latency is not that big on Solana streams. It really depends on your processing capacity. And some of our hackers, they have a hard time adjusting to Solana throughput because it's really large. And with
Yes.
tens of megabytes and frequent blocks times, I just wanted to highlight that we've recently released a Yellowstone gRPC plugin that provides similar capabilities to like Solana streams, but only for real-time data. You can create a Solana stream though, and it's very easy. You would use a block data set, and if I were to just illustrate the amount of data here from Solana mainnet, it even takes longer. It's like tens of megabytes. We have some helpful filtering code. They can take it down from like tens of megabytes down to something like a few kilobytes. And to illustrate, I have a helpful filter code on Solana that filters only token transfers. And here it is. So what it does, it checks incoming payloads and the balance changes, and then it puts it together in this payload here if there was any sort of transaction at all, because Solana can have empty blocks per slot. So these are the balance changes, and this return goes down to like a few hundred kilobytes from initial tens of megabytes, which is helpful for building some of the use cases. And it's a very reliable approach to dealing with historical and near real-time data. But for Solana hackers, I would also encourage them to give our Yellowstone gRPC plugin a try. We have it released on our marketplace. So once you explore those add-ons and look for Yellowstone, you'll find the add-on here. But that's about it. I think streams will cover most of the needs for EVM and Solana use cases, with some use cases, particularly like real-time critical, might be benefiting from this Yellowstone plugin.
Yes, absolutely. And you can find all the links in the comment section. You can find link to the Solana Streams beta, where you can sign up for the Solana Streams beta. And if you want to use the Solana Streams during the hackathon, we can obviously and definitely fast track your access to the Solana Streams. Just send a message. Just fill out that beta form and send a message in the Discord Streams channel, and we will give you access to Solana Streams. And if you want to use the Yellowstone gRPC add-on, you can, again, send a message in the Discord. So now that we have learned a lot about streams, I will highly recommend everyone to use that for their projects, because it's a very robust tool. It does everything which you can do with RPCs, plus a lot more. So now I will open up the stage for questions. So if you have any questions, or if you had any questions during the course of this stream, make sure to ask them now. And for people who are viewing this after the stream or the live stream has ended on YouTube, you can send messages on Discord if you get any questions while watching this recording. So if you have any questions, drop them in the comment section, and Nick or myself, we will be happy to answer them. All right. Looks like people got a really good understanding of streams, and they do not have any questions, which is good. But if you have any questions, again, reiterating that you can always send those questions in the Discord channels. We have a dedicated streams channel, and we will resolve your query or answer your question as soon as possible. So thank you so much for joining the stream, and thank you so much, Nick, for giving us this workshop, explaining us what streams are, and explaining us how to set up one. Thank you so much, everyone.
Thank you, Sohail.